Today I'm going to combine two of my favorite things, pizza and rocket stoves. And I'm going to build my dream pizza oven fueled by a rocket stove. I've partnered with Hobart on this video, and I'll be using their new Handler 140EZ for all of the welding. Now, I've built a few unique rocket stoves on the channel before, and I'm really excited about this one because we have a family tradition in the summer of cooking pizza outdoors, and we use a propane-powered pizza oven, and I think it'd be really cool to change that over to a wood fire on a rocket stove. Now, before I get too far down the road designing any project, I like to think through what I actually want to get out of it, some requirements, if you will. And so in this case, things like I want even cooking, I want an easy clean out so you don't have to dig a bunch of ash out. I want it to be freestanding so I don't have to bend over, adjustable temperature, those sorts of things. There's enough going on with this project. I decided to design the whole thing in CAD, and I'm using Fusion 360 today, and I started with a simple rocket stove burner and added the pizza stone followed by the oven enclosure. Now inside I designed a unique support for the pizza stone that should help give some even heating. I'll go over the design of that a little bit later. And then on the bottom, a unique lid to allow an easy clean out and a hole for a vent. So let's start by building the rocket stove burner. So I'm going to use this 4-inch square tubing because I had it here in the shop, and I built this whole project using remnants that I had in my junk pile, so I didn't buy any material with it, and that drove some of the design. I needed to cut a hole through the side for the feed tube to join into the main burner tube, and I just used a plasma cutter, but you could have done all of this cutting with a cutoff wheel and an angle grinder. I've built a ton of cool stuff before I had all these tools, and it works just fine. So I wanted to check the fit. Everything was fitting good, and now I just needed to cut the circles. I could have used a hole saw here, but I couldn't find one that was the right size, so I went with the plasma cutter to cut the vent holes for this damper right there. Right, we're ready to start sticking stuff together, and I'm going to be using the Hobart Handler 140EZ. The first welding machine I ever used was a Hobart Handler 120 back in the mid-90s, about 30 years ago. And my dad used that in his auto repair shop day in and day out, and I loved going down there, and I built all sorts of cool stuff with it, and that's really where I developed a passion for metalwork and welding. Now this is still a simple machine. There's no screens, no LCDs. It plugs right into a 120 volt outlet. On the front there are just two knobs for wire speed and voltage, except now there's an easy set mode. So instead of having to look up your settings on the door chart here, you can just turn this to the wire size that you have. So I'm running 030 wire, and then this just sets your material thickness like that with one knob. Turn it up, turn it down, and that's all there is to it. Now, even though this material is fairly thick, I turned the setting down to right around 16 gauge because I'm filling a little bit of a gap, and that's where the easy mode is really nice because I can just turn that one knob down a little bit, and I got a nice speed, and then I could turn it up when I was running these fillets here on the outside and inside, and I didn't have to look up any corresponding voltage settings. Next, I need to cut out all my sheet metal pieces, and I'm going to be using 1/8 inch or 3mm thick material for all of it, and I am cutting it out on my CNC Plasma Table. Now this is my third table. I built my first one and bought the second two, and it's worked pretty good. I know not everybody has a plasma table available to them, but you can upload your drawings to an online laser cut service like Send Cut Send, and they'll just send you your parts right out, and the price is much more affordable than it ever has been. Honestly, I think you're going to start seeing some fiber laser tables that can go in a home garage too with the more affordable fiber laser sources, but this worked here today. The next part I'm going to put together is the bottom of the oven itself. It supports the pizza stone and sits right on top of the burner, and I incorporated a few things into the design I want to show you. This hole right here, the flame will come directly up out of the burner into that. Now I want the flame to come up and around the oven and circulate like this and work its way out to the ends. And so the supports for the pizza stone I designed like this to block the flame from just coming straight up and out the door and the holes in the back to direct most of it out. But this row of holes should let a little bit of airflow through there so you get a nice even spread there. Now the rearmost support, and notice these are all tab and slot to sit in place. Now this rear support is just a little bit taller to give a backstop so my pizza won't slide off the back if I'm not perfect with the pizza peel there. And so that'll sit there like that. And in these slots along here, I'm going to have the support for the pizza stone itself, which is this piece right here. Now notice all these holes in it. I wanted to have some amount of heat shielding from the flame to the pizza stone to help it cook evenly. And the holes in this center section right here are a little smaller than the holes around this outside portion. And my hope is that right there where the flame's directly coming straight up at it will shield a little bit of heat and then allow more through here to cook evenly. So, that's my approach. We'll see how it works. Use a square to hold it, at least close to where I want it, and go for it. Well, the time has come to join the burner to the base of the oven here. I'm gonna just put a light tack on and check everything for square and then weld it out. Now, since it's good this direction, I can put one more tack over in this corner and then I'll correct it forward to back. So I gotta hold the square with my left hand, raise this up with my right hand till it hits it, and then throw a tack right in the middle up here.
I'm putting a fillet weld all the way around, and I'm doing each side by itself. Now, with some heavily loaded structures, it's important to wrap your weld around the corner to keep a crack from starting there. But when you don't have to do that, it's sure a lot easier to just approach each side independently, and then you can weld one side followed by the opposite, and that can help to counter distortion. I want my air to flow up from the bottom, so I want a lid on the feed tube, and I cut out this piece, and I'm just using some of these barrel hinges to hold it in place. These are always kind of difficult to get to fit just right in this setup, but I think I got it pretty good. The last major component I have is the lid on top, and this has some tabs on the bottom that just fit in slots below, and it won't be welded on so that I can lift it off to clean the whole thing out whenever I need to. Now, I would have saved a lot of time if I had a press brake to bend this top part around, and I could have cut some little relief slots to bend it by hand, but my experience has been that things fit together pretty well with these straight panels, and it's just a little bit more welding, so I'll get to test this machine out just a little bit more, and it should work out fine. Now, once I've checked everything for square, and if the parts are cut square, it should fit together pretty good just by itself, and it hasn't taken a lot of manipulation. So I can tack everything together and then get that top panel placed in. And once it's all sitting square and nice, I can run all these welds.
The welding is not going that good, and it's nothing to do with the machine. That's working great, but right here, see, I'm getting some porosity there, and I started to notice that, so I stopped and I checked my gas and nozzle. Everything was good. I start back up, weld a little bit to double check it. It's good. The rest comes out clean. Then on the next joint, I get the same thing. Porosity comes and then it goes. So I put in a mini split air conditioner last year, and I haven't had to use it this year until today. And it defaulted to this mode where it would shift where it's blowing up and down and back and forth. And it was cycling around and blowing my gas away. And so once I realized that, I turned off the air conditioner, and I got a clean run all the way along that outside corner. So I'll be grinding all these joints here.
There are a few things that are more frustrating to me than going to all this work to design and fabricate a project and having some issues with the welding, but I'm glad I got it resolved before I welded these front and back corners. And with the easy mode here, I'm just tracing right along my joint, and it's running really good.
Okay, well the front and back outside corners are done. I didn't run into any issue with porosity once I turned the air conditioner off. I'm pretty hot in here, but the welds came out nice and clean. Now as far as the porosity that's left here after I ground it out, since this is a personal project and it's just a pizza oven, I'm gonna leave it alone. Once I paint over it, it won't really be a big deal. But if this was for somebody else, or if it was, you know, any kind of load-bearing joint, I would go through there and then go in with a cutoff wheel, and you really have to grind it all out and then go in and re-weld the whole thing. If you try to just weld over this porosity, it'll usually just keep coming back from my experience. But in this case, I'll just grind it down the best I can and roll with it. Fabrication of the actual oven is done. Now I just need to build a stand for it. So what I came up with is just some tubing that'll angle off of the back here and down, and I'll have one on either side of this rectangular tubing to give a little rigidity, and then that will be welded right to this rectangular base.
Now I'm going to use my fixture table for this because I need two identical parts, so I can build a little fixture that'll make sure that all of the interfacing areas line up in the exact same place and then weld it together. And this works really well. For many years I didn't have a fixture table, and I built stuff that's much more complicated than this with it. And you can either weld little dogs to your table, or you can just draw out your interfacing lines and then clamp everything down, or just tack it and work your way through. And it'll work out just fine, but if you do have one, it sure is a big time saver. I'm just going to use some pop rivets to hold this vent in place before I look at the lid to fit on the bottom.
So this is the cap for the bottom, and I just bent this piece right here, which will sit on top of it to support the fire, but it'll drop out with the whole thing. So all of the ash, both above and below the grate, can just fall out into a bucket. In the end, the max temperature that the pizza stone itself reached was 620 degrees. And the best that I can tell, the inside temperature in the oven was around 450. Now that is not as hot as my gas-fired one, and I'd like to find a way to increase that temperature. I have a few ideas to try. Increasing the airflow, maybe removing those vents on the sides and using some other sort of damper so that I can get more air through. Two, maybe some different fuel, either different sizes of sticks or change over to a hardwood with a hotter flame. Perhaps I could do some insulation on the top or change the way that the exhaust ports work. Let me know what you think I should do there in the comments, but it did still work well. I mean, the pizza was cooked all the way through, the dough was nice, the top was cooked nicely before the bottom was burned. It just took a little bit longer than my gas-fired one. So maybe it's fine to just leave it alone, I don't know. Now the Hobart Handler 140 worked great if you're not welding heavy gauge stuff. Definitely a really good option. So thanks to them for their support today, and thank you for tuning in. Now, if you are just learning to weld or you want to learn to build projects like this, you can learn much faster with hands-on exercises that are focused on one thing at a time. And I have a set of online courses that'll walk you through that step by step. That's how I support these videos, and I'm able to do this. So be sure to check those out, linked in the description below. Thanks again for tuning in. We'll see you next time.